Hello everyone, this is Layer PCB, your trusted PCB partner. Today we'll be introducing the art of double-sided PCB layout, laying the foundation for success. A common misconception is that PCB design is mainly about routing traces, but in reality the layout determines the true potential of the design, and routing simply realizes that potential. A scientific layout can fundamentally solve 70% of electronic compatibility issues and make the subsequent routing work much more efficient. Today, let's dive deeper into the art and practical strategies of double-sided PCB layout. First, let's consider strategy 1. This involves the crucial process of mapping from functional blocks to their corresponding physical blocks. Before you start working by hand, you must review the schematic and form a functional map in your mind. First, clearly divide the schematic into functional modules based on their logical functions such as power input, protection, main control, MCU unit, memory unit, human-machine interface, high-speed communication interface, analog signals, and power drive. Then, during PCB layout, treat these functional modules as whole units and find suitable physical locations for them on the PCB. For example, on this particular board, the functional divisions are quite clearly defined. This section is dedicated to the MCU module, that area handles the power module, and further above are some sophisticated analog RF processing modules. There are distinct and well-organized separations and logical groupings. For this part is the LED control. Since the position of the LED is fixed, its control circuit is placed close to the LED. First of all, the principle of high cohesion and low coupling, a classic concept in software engineering, also applies to hardware layout. Components within a module are placed closely together to ensure the shortest and most direct internal connections. Modules are connected to each other only through a small number of well-defined, clear interfaces, making management easier. Take the power module as an example. All related components are placed very close to each other, forming a single module. The same goes for the MCU. Its crystal oscillator, decoupling capacitors, and so on are grouped together and placed as close as possible to the chip. Then, for interactions with other modules, such as these control lines, they can be routed farther away. Next is visual management, which means grouping components of the same functional module together. During the layout process, I usually first cluster them together outside, and then drag them into their specific positions for placement. We can also take a quick look at this 3D effect. As you can see, there are many capacitors and resistors around the chip. This forms a module with the chip at the center, creating a small functional block. Layout strategy 2. Structure first. Establish an unshakable framework. The first step is not to place the CPU, but to determine the backbone of the entire board. So first, you need to import the fixed structural elements and bring in the mounting holes and short frames that precisely fit with the product's casing from the structural files, usually DXF files. Let's take a look at the result after importing them. First, you need to select the bottom layer. It defaults to the top layer. I usually place it on the top silkscreen layer and then adjust it according to different positions. For example, I might move the outline to the keyboard layer or the outline layer. You can see that the structural engineer has done an excellent job with the design, clearly specifying the positions of all the components and describing their outlines. This way, we can clearly identify, for example, this corresponds to the switch, this to the USB, and this to the button. The LED and other interfaces above are also very clear. I can then use this structural file to design these openings as slots or keyboard features and set up the outer frame. This allows me to place and lock all the components that need to fit with the structure first. That is, place and lock all the external interface components. Just like I mentioned earlier, make sure all these external interfaces are properly placed and then locked, and then place the human-machine interaction buttons. If there are some buttons inside that don't need to interface with the structure externally, such as reset buttons or indicator lights, those should be placed as well. For these, the first thing to consider is that there should be no obstructions. For example, in my case here, I haven't placed a reset button, so I need to think about the operation first. Generally, it should be placed near the edge and kept away from other taller components to avoid any blockage. These structural components serve as the foundation and constraints for the entire design. By fixing them in place first, the subsequent layout will have clear boundaries and references. Otherwise, if you end up discovering that the CPU blocks the installation opening or the USB port can't fit into the enclosure, it would be a disastrous mistake. And then there's 3D verification. Nowadays, EDA software all supports 3D dependencies. After placing the structural components, it's strongly recommended to perform 3D dependency checks and match them with the product's 3D structure to identify any interference issues in advance. For example, after I finish designing or even during the design process, I usually check the 3D model to make sure the placement of these components is appropriate and there are no interferences. You can even export it as a 3D file and give it to the structural engineer for further verification, ensuring perfect coordination between the design and the structure. Alright, that's all for today's comprehensive content. In the very next episode, we will definitely continue our in-depth discussion about other fascinating and effective layout strategies. If you thoroughly enjoyed this informative video, please consider subscribing to my channel for even more valuable and engaging content. Thank you all very much for your time and attention.